now we want to introduce angle and intersection between two planes. We first introduce angle between two planes. All right, as you can see, we have two planes right here on the graph. So one plane is, sorry, my Apple Pencil is not working. All right, there you go. All right, so one plane is the angle between this is right here, the green part, so between these two. But if you notice that this angle is the same angle between the two normal vector. So n1 is the normal vector of the flat one right here. n2 is the normal vector of the slanted one right here. So this angle and this angle are the same. Just erase that. So these two angles are the same. Okay, so angle between two planes is the same thing as angle between two normal vector. Moreover, notice that this intersection right here, the straight line, we want to find the line equation of the intersection between two planes. So here's the question right here. Okay, all right. Find the angle between two planes, x plus y plus z equals to 1, and x minus 2y plus 3z equals to 1. B, find a symmetric equation of the line of the intersection L of the two planes. So first, let's look at A first. Okay, so the angles well, we just know it's between the two. So it's the same. The angle between the two planes is the same as the angle between two normal vectors of the planes. Well, we already have those two, right? Because we know the coefficient of x, y, and z is a normal vector. So we can say that it is the angle between the two vectors. All right, I just call 1, 1, and 1 for the first plane, and the second plane is 1, -2, and 3. All right, we know how to do that, right? Remember the dot product? A dot B equals the length of A times the length of B times cosine theta. So we know that theta here is arc cosine, is the dot product on the top. So 1, 1, 1, dot 1, -2, 3, divided by the length of both, the square root of 1 plus 1 plus 1 times square root of 1 plus 4 plus 9. So it's arc sine of, let's see, 1 minus 2 plus 3 divided by square root of 42, which is cosine, arc cosine of 2 over square root of 42, which is about 72 degrees. All right, the second question is involving find a line equation of the two intersecting planes. So how do we do that? Let's just see. Let's take a look at the graph maybe. That will help. All right. So that's actually the graph of the two planes. Okay. So how can we think about this? How do we think about this? Right, we actually want to find the line equation right here, this line, the intersection, this line. All right, so to find a line equation, we need to know two things, right? Line equation, we need to know A, the direction vector, and the second, we need to know a point on the line. Well, we need to know the point on the lines. Well, remember, any point on this line satisfies both equations, right? So we have two equations with three variables, so we'll have infinitely many solutions. Obviously, there are infinitely many points on the line. So what can we say this, right? We want to find one point, one solutions to the system of linear equation x plus y plus z equals to 1 and x minus 2y plus 3z equals to 1. Okay, so we have three variables, so one is a free variable, so let's just say pick z to be what? How about easier, 0. Then we need to solve x plus y equals to 1, x minus 2y equals to 1. Happen to be solutions x, y equal to 1, comma 0. So we can conclude that 1, 0, 0 is on the plane, on the line. We got that. Next, how do we find the direction vector of the line? The direction vector of the line, well, let's think about this. Let's look at the plane from the sideway viewpoint. If I look at this two plane like this, okay, I would say this is x minus 2y, 2y plus minus, my bad, x minus 2y plus 3z equal to 1, and this is the line of x plus y plus z equals to 1. All right, so the line is right here. It's the red dot right here coming either toward you or away from you. So how do we find the direction vector of the line? Well, let's think about that. Both plane has a normal vector. This guy has a 1, negative 2, 3. The other one has a direction vector. Normal vector is 1, 1, and 1. Well, look at that. If I cross product these two vectors, just two normal vectors, this vector and this vector, that cross product will be what? Either the red dot coming toward you or away from you. So the direction vector of the line is the cross product of 1, 1, 1, and 1, negative 2, 1. So let's find that. So the direction, we can go ahead and do that. I, j, and k, 1, 1, 1, 1, negative 2, 3. All right, so for time matter, I'm just already going to abbreviate that. I trust that you know how to find that. That's equals to 5i minus 2j minus 3k. So the direction factor is 5 minus 2 minus 3. And we already know a point on the line, right? The point is what? The point is 1, 0, 0. So the symmetric line equation is this, right? So it will be x minus 1 divided by 5, y minus 0 divided by negative 2, and z minus 0 divided by negative 3. So that's our line equations.